Hello everyone, I am Professor Amit Thakur. Today's session we are going to see the sorting algorithms of selection sort, operations and implementation in C. In this topic we are going to cover like what is selection sorting, working of selection algorithm, selection sorting complexity, application of selection sorting, where and when to use selection sorting and advantages and disadvantages of selection sorting. So, after this session or end of this session you will be able to know what is selection sorting and the working style of selection sorting algorithm, selection sorting complexity and the application of selection sorting and when and where to use this kind of sorting selection sorting, and at last we will discuss the advantages and disadvantages of selection sorting. So, first we discuss about what is selection sorting. Selection sort is a simple comparison based sorting algorithm that works by dividing the input list into two parts, the sorted part and the unsorted part. Initially the sorted part is empty and the entire list is considered unsorted. The algorithm repeatedly finds the minimum element from the unsorted part and moves it to the end of the sorted part. This process is repeatedly until the entire list is sorted. Now, here how the selection sort works. Here are the basic steps of selection sorting algorithm. The first step is find the minimum element in the unsorted part of the list. So, the second step is swap this minimum element with the first element in the unsorted part and effectively moving it to the end of the sorted part. The third step is expand the sorted part to include the element that was just moved and shrink the unsorted part by one element. And the last step is repeat step 1 to 3 until the unsorted part becomes empty and the entire list is sorted. In selection sort, the smallest value among the unsorted elements of the array is selected in every pass and the inserted its appropriate position into the array. It is also the simplest algorithm and it is an in place comparison sorting algorithm. In this algorithm, the array is divided into two parts. The first is sorted part and the another one is the unsorted part. Initially, the sorted part of the array is empty and the unsorted part is given array. The sorted part is placed at the left while the unsorted part is placed at the right. In selection sort, this first smallest element is selected from the unsorted array and placed at the right position, or maybe we can say the first position. After the second smallest element is selected and placed in the second position. The process continues until the array is entirely sorted. Selection sort is basically used when the following conditions. The first condition is the small array is to be sorted. Second is swapping cost does not matter. And third is it is compulsory to check all elements. Selection sort has a time complexity like order of n square, where n is the number of elements in the list. This makes it inefficient for the large list and the performance deteriorates or decreases repeatedly as the list size increases. However, it has the advantages of being easy to understand and implement, and it performs a constant number of swaps which can be useful in situation where minimizing data movement is priority. Now, we will see what is the algorithm of selection sort. The selection sort algorithm can be described with the following steps like in pseudocode. First of all, we will take the one array and we will calculate the size of the length of that array and we will put that value into the variable, any variable like n here. And the next step is traverse through the entire array from 0 to n minus 1, that is n is the number of elements in the array, and next step is assume the current element is the minimum value. So, we will assign that I value to the mean index. After this, we will try to find the index of minimum element in the unsorted part of the array. For this, we will have one j loop and j loop iterates from I plus 1 to n minus 1, and inside this loop we have one condition is like ARR of j less than ARR of mean index. If this condition satisfies, then we will put the value of j into mean index. Basically, we are try to change the value of min index if the condition satisfies. And the next step is swap the minimum element with the first element in unsorted part. For this purpose, we need to call a function like swap function. In this swap function, we takes two parameters. The first parameter is array and second parameter is error of index, minimum index. In this pseudocode, here ARR which I have mentioned over here is the input array that you want to sort. Here n is the length of the array. The outer loop iterates through the array from the first element, that is I equals to 0, to the second last element, that is I equals to n minus 1, and the last and the next element, that is next loop, that is inner loop, starts from like find the index of the minimum element in the unsorted part of the array. The minimum elements index is sorted in min index. Min index here is a variable name. After finding the minimum element in the inner loop, a swap operation is performed between the element at the index of I and the minimum element found in the unsorted part of the array. This process continues for each element in the array, gradually building the sorted part of the array. Suppose like we need to see how this algorithm works. So, suppose we are taking one example like error of we have taken one array and we have initialized the value like 64, 25, 12, 22, 11. So, we have taken these values. In first pass, the first position in the sorted array, the whole array is traversed from index 0 to 4 sequentially. The first position where 64 is sorted stored it presently, after traversing the whole array, it is clear that 11 is the lowest value. Thus, replace 64 with 11. Here we are going to swap these two values. After one iteration, 11 which happens to be the list value in the array tends to appear in the first position of the sorted list. In second pass, for the second position where 25 is present, again the traverse of the rest of the element in a sequential manner. After traversing, we found that the 12 is the second lowest value in the array and it should be appear at the second place in the array. So, thus these two values will be swapped. Now, you can see this value is swapped. Now, we talk about the third pass. Now, the third pass, the third place where the 25 is present, again the traverse the rest of the array and find the third list value present in the array. While traversing, 22 came up to be the third list value and it should appear at the third place in the array. Thus, swap 22 with the element present in the third position. So, you can see this example, the value is swapped with 25 and 22 because it is matching, or if the value is list, then the value will be swapped. At fourth pass, similarly the fourth position traverse the rest of the array and find the fourth list element in the array. At 25 is the fourth lowest value over here, it will replace at the fourth position. So, you can see this value is replaced with the fourth position, the minimum element is 25 over here, hence the swapping is not required because already 25 is less than the 64. At the fifth place or fifth pass, at last the largest value present in the array automatically gets the place at the last position in the array. Now, we can see the resulted array is the sorted array. Now, you can have the elements like 11, 12, 22, 25 and 64, it is sorted array. Now, we will see the implementation part of this sorting, this selection sort using C. For this purpose, we are going to take one header file like stdio.h that needs to be included. Inside this, after this we are taking main function. Main function we are taking one array of this 10 size, the size of array is 10, and now I have initialized this value with 6, 12, 0, 18, 11, 99, 55, 45, 34 and 2. So, these are the initial value of the array. Here n equals to 10, which I have already described in my code, and also we have taken some variables like I, j, position and swap. After this, we are taking one loop, I loop. The I loop starts from 0 to n minus 1. Inside this loop, I have initialized the position value with I that is position equals to I. After this I am taking another j loop. J loop iterates from I plus 1, this is the next value of I up to j less than n, and after this I am simply putting one condition over here. If condition like error of position is greater than error of j, means I am just trying to compare these two values. If this satisfies, the value of j will be assigned to the into the variable position. After this loop I am taking another condition. If position does not equals to I, if this condition satisfies, I need to swap these two values, like error of I value will be assigned to the swap, error of position, the value of this will be assigned to the error of I, at the last the value of swap will be assigned to error of position. So, this is basically a swap condition over here, and at the last we need to print the sorted elements. So, for that purpose I am taking one loop starts from 0 to n minus 1, and simply I am writing the printf method, and inside this printf method I am simply printing the error of value, and the last I am returning 0. So, now we will talk about the complexity of the selection sort. The selection sort algorithm has a time complexity of order of n square, where n is the number of elements in the input array. This means that the size of the input array increases, the time it takes to sort the array this array increases the quadratically. The reasoning behind this time complexity is as follows. First, the outer loop runs for n iterations, where n is the number of elements in the array. This is because in the worst case you need to compare each element with every other element. Second, the reason is the inner loop, that is j loop, which I have discussed earlier, which finds the minimum elements in the unsorted part of the array, and also runs for n iterations in the worst case. In this case, each iteration of the outer loop it iterates through the remaining unsorted portion of the array, which decreases the size by 1 with each iteration. Now, the third reason is within the inner loop you perform constant time operations for each pair of the element. Since we have two nested loops and each running for n iterations, the overall complexity will be like order of n square. It simplifies like because we are taking two loops for n times. So, it simplifies like order of n square. Selection sort is not the most efficient sorting algorithm for large data sets, but it is easy to understand and implement. It is often used for educational purpose in situation where the simplicity of the algorithm overweights its inefficiency. Selection sort is one of the simplest and the oldest sorting algorithm dating back to early days of computer science. It was originally proposed by John Mauchly in 1945, who was a pioneer in the field of computer architecture and one of the designer of the ENIAC, one of the earliest electronic general purpose computers. However, it was not widely known or used until it was popularized by Donald Knuth in his influential book. The title is The Art of the Computing, like computer programming. It is published in year 1960s and also in year 1970s. The basic idea behind selection sort is which involves repeatedly selecting the minimum elements from the unsorted part of the list and moving it to the sorted part. It quite intuitive and easy to implement. This simplicity made this algorithm is very attractive sorting method of early computer programmers and educators, as it provided a clear example of sorting algorithm. Whilst selection sort is not the most efficient sorting algorithm, it played a significant role in the history of computer science and programming education. It served as an introduction to the sorting algorithm for many students and helped to lay down the foundation of understanding more complex and efficient sorting algorithm such as quick sort or merge sort and so on. Over the time, as computer hardware and software development advanced, more efficient sorting algorithms were developed and became the standard for practical applications. Nevertheless, the selection sort remains a valuable teaching tool and historical milestone in the evolution of sorting algorithm. Now, we will discuss the applications or application of sorting algorithm. Selection sort is a simple and straightforward sorting algorithm. Despite its inefficiency and for large data sets, can still find the application in certain situation where simplicity, ease of implementation or specified requirements are more important than the sorting speed. Here are some potential applications of selection sort. The first application is teaching and learning. Selection sort is often used in educational settings to introduce students to the concept of sorting algorithm. Its simplicity and ease of understanding make it a valuable teaching tool for demonstrating the basic principles of sorting. Second application is small data sets. When dealing with very small data sets, the performance differences between the selection sort and more efficient sorting algorithm may not be significant. In such cases, selection sort can be a quick and easy choice. Third application is embedded system. In resource constraints environment such as embedded system which limited memory which has limited memory and processing power, selection sort might be a suitable choice due to its low memory overhead and straightforward implementation. The fourth application is special cases. There are some special scenario or specific scenario where selection sort can be advantageous. For example, if you are sorting a data with certain patterns or constraints that that make it easier to identify the minimum element efficiently, selection sort can be useful. The next application is parallel processing. Selection sort is relatively easy to parallelize because each iteration of outer loop involves finding the minimum element, which can be done independently for different portion of the list. In this situation where parallel processing is critical, selection sort may have some advantages. Next application is online algorithm. In some online or streaming data application, you may need to sort data continuously as it arrives. Selection sort can be adopted for such situation where it can efficiently maintain a partially sorted list by inserting new elements into their correct positions. Next application is situations with few writes. Selection sort performs a relatively small number of swaps compared to other sorting algorithm. If minimizing the data movement it is more important than the comparison operation, then selection sort might be preferred. Next application is debugging or verification. Selection sort is easy to implement and can be used as a reference or baseline for verifying the correctness of more complex sorting algorithms. It can help to ensure you that your more advanced sorting algorithm that are working correctly. It is important to note that in most real world applications where sorting is a frequent operation on large data sets, more efficient algorithm like quick sort, merge sort or heap sort are preferred due to their significantly better time complexity. The selection sort is primary role is often educational and as a simple sorting method for a small scale or specialized application. Now, we will talk about the advantages of the selection sort. Selection sort, while not most efficient sorting algorithm, does not have few, but it have some few advantages also. The first is its simplicity. Selection sort is often called as a simple algorithm, or also it is some of the simplest algorithm that is to understand and implement. It is often used as a teaching tool to introduce the concept of sorting to the beginners. Its straightforward nature makes it good starting point for learning about sorting algorithm. The second advantage is in place sorting. Selection sort is an in place sorting algorithm, which means it does not require additional memory to sort the data. It operates directly on the input array or list, making it memory efficient. The next application is stability. Selection sort is a stable sorting algorithm. It means it preserves the relatively order of equal element. If maintaining the original order of equal element, it is important in your application. Selection sort can be a good choice. Next is adaptivity. Selection sort's performance is not dependent upon the initial order of elements. It performs roughly the same number of comparisons and the swaps regardless of whether the input data is partially sorted or completely unsorted. This can be an advantage in some situations. Next application, low overhead. Selection sort has a relatively low overhead in terms of extra variable and logic compared to some other sorting algorithm. This can be an advantageous in situation where minimizing code and the complexity is priority. Next is small data set. For very small data set, the performance differences between the selection sort and more complex sorting algorithm may not be significantly. In such cases, the simplicity of the selection sort might be outweigh its slower performance. Selection sort is advantageous for its simplicity, in place sorting nature, stability and the adaptivity to input data. It can be suitable for educational purposes, small data sets and situations like where the code simplicity and the memory efficiency are more critical than the sorting speed. However, it is not the best choice for sorting algorithm for large data sets due to its quadratically time complexity. Now, we will talk about the disadvantages of selection sort. Selection sort, while the simple to understand and its implement has very easy, has several disadvantages also that makes it inefficient and less suitable for sorting large data sets. The first is quadratic time complexity. The most significant disadvantage of selection sort is its time complexity. It has the worst case and average case time complexity like order of n square, where n is the number of elements to be sorted. This means that the input size grows. As input size grows, the time it takes to sort the data increases quadratically. For large data sets, selection sort becomes extremely slow compared to more efficient sorting algorithm with order of n into log of n time complexity. Next is the disadvantage is lack of adaptivity. Selection sort does not adapt to initial order of the elements. It performs the same number of comparisons with swaps regardless of whether the input data is partially sorted or completely unsorted. This lack of adaptivity makes it inefficient in practice where dealing with real world data. Next disadvantage is inefficient for large data set. Due to its quadratic time complexity, selection sort becomes impractical for sorting large data sets. It is much slower than more advanced sorting algorithms like quick sort, merge sort or heap sort, which have better average and worst case time complexities. Next disadvantage is lack of stability. While selection sort is stable in terms of maintaining the relative order of equal elements, it does not guarantee that the stability of the entire sorting operation. If there are equal elements in the input data, their relatively order may change during the sorting process depending upon the algorithm's implementation. Inefficient for nearly sorted data. Selection sort is its simplicity comes at a cost. It does not take advantage of any existing order in the data, making it inefficient for nearly sorted or partially sorted data sets. More advanced algorithms like insertion sort or adaptive sorting algorithms are better suited for such scenarios. Next disadvantage is high number of swaps. Selection sort requires a relatively high number of element swaps, especially when compared to other sorting algorithm. Swapping elements can be an expensive operation, particularly in scenario where memory access is slow, such as sorting the large arrays. The primary disadvantage of selection sort are its poor time complexity, lack of adaptivity and the inefficiency for sorting large data sets. While it has its use cases for educational purposes and small data sets, it is generally not recommended for practical applications where sorting efficiency is crucial. Now, we will talk about where we can use this selection sort in real life. Selection sort is simple sorting algorithm that is primarily used for educational purposes, and it is rarely used in real life application due to its inefficiency or depending upon the larger data set. However, you can find situation where selection sort might be used in practical, especially in where specific and constrained scenarios. The first application is small data set. Selection sort can be reasonably efficient for small data sets where the number of elements to be sorted in relatively low. In such cases, the overhead of the more complex sorting algorithms may overweight the benefits or outweighs the benefits. Second application is embedded system. In resource constrained environment such as microcontrollers and embedded systems with limited memory and processing powers in selection sorting might be preferred over some complex sorting algorithms because its simplicity and minimizing the memory usage. The next application is teaching and learning. Selection sort is often used in educational settings to teach the concept of sorting algorithms. It provides a straightforward example for students to understand the sorting principles and algorithms before moving on to the more advanced techniques. The next real world example is like debugging or small scale scripting. In some scripting or debugging scenarios, you might use selection sort for its simplicity and ease of implementation, where sorting small sets of data for diagnostic or testing purposes. Next application is partial sorting. If we need to find the smallest or largest element in the data set or in array, rather than fully sorting it, a partial selection sort can be useful. You can use a variant of selection sort to find the minimum or maximum value in the linear time complexity, where it can be more efficient than the fully sorted the data. However, in most real life applications and scenarios involving the larger data sets or where the sorting efficiency is critical, more sophisticated sorting algorithms like quick sort, merge sort, heap sort are preferred due to their superior performance characteristics such as better average and worst case scenario, time complexity. These applications, these algorithms or applications are optimized for real world sorting tasks, such as they are readily available in programming libraries and frameworks. Now, we talk about some facts about this sorting algorithm. An interesting fact about sorting algorithm is that it is not affected by the input data's initial order when it comes to the number of comparisons and swaps it performs. In other words, whether the input data is partially sorted, completely unsorted or sorted in reverse order, selection sort will always perform roughly the same number of comparisons and swaps. This property is known as the invariance of relatively order, and the sets selection and sets the selection sort apart from the some other sorting algorithm. For example, consider the sorting a list of numbers using selection sort. If the list is already sorted, selection sort will still perform the same number of comparison and swaps as if the list were the reverse order of or randomly shuffled. If you partially sort the list, the selection sort is performance remains the consistent. This property can be seen as a both an advantages and the limitation of selection sort. It is an advantage because it makes the algorithms predictable and independent of the input data's initial state. However, it is a limitation because despite the simplicity, selection sorts time complexity remains order of n square, making it inefficient for the sorting larger data sets. Difference between insertion sort and selection sort. Insertion sort and selection sort are two popular sorting algorithms, and their main characteristics or main differences lies in how they select and place the elements in sorted sequence. In insertion sort, the input array is also divided into two parts, a sorted part and unsorted part. The algorithm picks up the elements from the unsorted part and place it in the correct position in the sorted part, shifting the larger elements from one position to the right. Insertion sort has insertion sort has the time complexity of order of n square in the worst case, but can be performed better on particularly sorted arrays with the best case time complexity of order of n. Selection sort scans the unsorted part to find the minimum element, while insertion sort scans the sorted part to find the correct position to place the element. Selection sort requires fewer steps or fewer swaps than the insertion sort, but more comparisons. Insertion sort is more efficient than the selection sort when the input array is partially sorted or almost sorted, while selection sort performs better when the array is highly unsorted. In summary, both algorithms have similar time complexity, but their selection and the placement methods differ. The choice between them depends upon the characteristics of the input data and the specific requirements of the problem at the last. Now, we will move to the conclusion part. Selection sort is a straightforward yet inefficient sorting algorithm that works by repeatedly selecting the minimum elements from an unsorted portion of the list and moving it to the beginning. While it processes this it possesses the simplicity and ease of implementation, its primary drawback lies in its quadratic time complexity, making it impractical for sorting large data sets. The following are some applications how to use selection sort. Selection sort are consistently outperforms bubble and genome sort. When memory writing is costly operation, this can be useful. In terms of number of writes like n, swaps versus the order of n square, selection sort is a preferable to insertion sort. It is almost always for out number of writes made by the cycle sort, even though cycle sort is theoretically optimal in terms of the number of writes. This is important if writes are significantly more expensive than the reads, and with the EPROM or EEPROM or flash memory where each write reduces the memory's lifespan. Selection sort's predictable behavior, stability, in place sorting make it suitable for educational purposes and small data sets, where the code simplicity or memory efficiency may be more valuable than the sorting speed. However, in most real world applications, especially those involving substantial amount of data, more efficient sorting algorithms like quick sort, merge sort or heap sort are preferred choices due to their superior time complexity and adaptability due to various data scenarios. So, with this I conclude my session. Thank you so much.